So we talked a little bit about 7.6 in class when we first started chapter 7. 7.6 doesn't give us anything new, but what it does do is it looks at different solutions to linear systems. Okay? When we were graphing, we were finding that the lines would crisscross once. That would give us a solution. Sometimes we'd find that those lines would be parallel, which they would never cross, so there'd be no solution. And then there's a third one in which, well, if the slopes and the y-intercepts were exactly the same, that they would overlap each other, and there would be infinite solutions, and we have special names for those. So lines that crisscross once are called intersecting. Lines that are parallel and never cross are called obviously parallel. And then when they overlap each other because they're exactly the same equation, just written in different forms, and we can't necessarily see that, we call them coincident, which means if we did graph them, that they would land right on top of each other, and we wouldn't be able to tell the difference. Okay? And then the characteristics of those are, well, in intersecting lines, the slopes are different, and the y-intercepts could be the same or different, but it's the slopes that are different that allow them to crisscross. We get one solution, that's where they cross, and then if we looked at this, you could see that their slopes are different, but in this case, their y-intercepts are different as well, and we wouldn't necessarily be able to notice that. And if we were to graph those, we'd simply end up with a couple of graphs that crisscrossed somewhere. Now, I'm not saying those are the right graphs, but it would be something similar to that. Okay? If we had parallel lines, the slopes of the equations would be the same. Slopes would be the same. The y-intercepts would be different though. Okay? And in this case, there'd be no solution. Sometimes when we look at the equation originally, we can't really tell that, so we rearrange it. If we rearrange equations into slope-intercept form, they're comparable. If we don't have them in that, it's really difficult to see similarities and differences. So rearrange them into slope-intercept form. You'll see that the slopes are the same, but the y-intercepts are different. So we would end up with two lines that would might look something like that. They'd be parallel, they would never cross. Okay. And then our coincident lines, same slope, same y-intercept. Infinite number of solutions because they are overlapped. Okay. If we have two equations, we may not necessarily be able to see that they are exactly the same equation. You could see that if I multiplied this by a factor of 3 that they would become the same. Sometimes you wouldn't necessarily be able to see that though. If we rearrange into slope-intercept form, they would become exactly the same. And you can see that they both have the same slope. They both have the same y-intercept. They would end up being graphed right on top of, well, I guess I can do a straight line, can't I? Right on top of each other. Difficult to show that. All right. So we have those three different types of graphs. And that leads us to two other terms. Consistent is a system that has solutions, so they're intersecting or coordinate lines. Okay, not coordinate, coincident, they overlap. And inconsistent, a system that has no solutions. Okay, so a couple of terms to remember as we work through some problems here. So example 1a, determine whether each line has infinitely many solutions, no solutions, or one solution. Label as consistent or inconsistent. So if we look at this, in order to compare equations, we need to have them in the same form. So we need to have them both in slope-intercept form. So I'm going to take each equation, 3x plus y is equal to 9, and I'm going to rearrange it into y equals mx plus b. So I'm going to subtract 3x, subtract 3x. That's going to give me y is equal to negative 3x plus 9. And I do the same for the other equation, which I'll do in blue. 6x plus 2y is equal to 6. I'm going to subtract 6x minus 6x. That'll leave me 2y is equal to negative 6x plus 6. Divide by 2, divide by 2, divide by 2. That will leave me y is equal to negative 3x plus 3. So we can see that these two graphs have the same slope but different y-intercepts. Okay? So if you remember the terminology, well, that's great. If you don't, we go back to our graph. Same slope, different y-intercepts. We have parallel lines, and parallel lines are inconsistent. No solutions. So we have parallel lines, and they would be inconsistent. Let's look at example B. 3x plus y is equal to 9, and 6x plus 2y is equal to 18. So if I quickly rearrange this into slope-intercept form, 3x plus y is equal to 9, minus 3x, minus 3x. I'm left with y is equal to negative 3x plus 9. Over here, I'm going to subtract 6x, 2y is equal to negative 6x plus 18. Divide by 2, divide by 2, divide by 2. Y is equal to negative 3x plus 9. Well, look, lo and behold, we have an equation that has the same slope. We also have an equation with the same y-intercept. If you remember, that's great. If you don't, we check our table. Same slope, same y-intercept. We have coincident lines, and coincident lines are consistent. There is a solution. So we have coincident lines, and they are consistent. That's example 1. Back in the next video for example 2, working through these.